Hello everybody, again this is Mr. Bright and I'm in room 225. If you ever have any questions, I'm always available in the mornings. You're welcome to come by. And very soon I will also have an afternoon time that I'm available. So far we have covered different types of factoring. First step was GCF factoring, and remember, you always look for a GCF before you start any problem. Always look for a GCF first. The second thing we did was factoring by grouping. And so today what we're going to do is we're going to factor trinomials. Now, I'm going to show you a way that maybe you have not seen before, and I like it a lot. I think it works really well. My students tend to like it. And we're going to factor trinomials, and we're going to use factoring by grouping to do it. So hopefully the factoring by grouping worked out okay for you. If it didn't, come see me. Let's make sure we get you squared away there. All right, so a trinomial is a polynomial that has three terms, 1, 2, 3, and also we're looking for something that is quadratic, so that means its exponent, largest exponent is a 2, so we have a variable that's squared. We have what's called the linear term, because this variable is just raised to a 1 power, right? When there's no number there, it's a 1. So we have a linear term, and then we have a constant, right? The quadratic term, the linear term, and the constant. So this gives us a trinomial. Now, what you may have heard this referred to in the past is as the AC method, and that's still going to be kind of what we use. You may recall that the format is ax squared plus b, well, I really shouldn't do it that way, bx plus c, where a, b, and c all represent numbers. So in this particular case, the a would be the 1, right? Not the k squared, but the a is the 1, the b is the 8, and the c is the 16. And so in the AC method, what we typically tell you to do is to take the a term and the c term and multiply them together. So in this case, that would be a 1 times 16, which obviously is equal to positive 16, right? Both of these numbers are positive, and so our 16 is also positive. And then we take that number and we factor it. And we do it a little differently. We don't do a factor tree. What we do is we do 1 times 16, or 2 times 8. 3 doesn't go into 16. 4 times 4, and then there's no other number that goes into 16 that I haven't already used. And so all of these numbers, if I multiply them together, I get 16. 2 times 8 is 16. 4 times 4 is 16. Now, here's kind of a little wrinkle in this. While this 16 up here is positive, I don't know if it's positive because I multiplied two positive numbers together or because I multiplied two negative numbers together. And so you always have to think of these as being either positive or negative. We're not sure yet. We just know that they have to multiply to give me a positive 16. So that's our first step. Multiply a and c together, you get the 16. You factor that out into all the different pairs of numbers that can multiply to give you 16. And now the next piece is to find a pair of these numbers, either this one, the middle one, or the last one, that when added together gives me the b, the positive 8. Well, clearly that's the 4 and the 4. And since they add to a positive 8, not a negative 8, they must both be positive. And so the two numbers I'm going to use are positive 4 and positive 4. Now, this next step, you've probably seen a lot of this before, but this next step is going to be different. And on this particular problem, it doesn't make a huge difference whether we do it this way or not, but I want you to see this method and learn this method because I think you'll find it really useful when these problems get more difficult. So this is what we're going to do. We're going to take this 8k and we are going to rewrite it as 4k plus 4k. So let me show you. This whole problem, this whole thing is going to be rewritten like this. K squared plus 4k plus 4k plus 16. All right, now, does it make sense that this right here gives me that 8k right there, right? 4k plus 4k is 8k. So this whole expression is mathematically identical to this expression. It's k squared plus 8k plus 16, k squared plus 8k plus 16. But now I've converted it into something that I can use factoring by grouping on. And so that's my next step, is to do factoring by grouping. Now, I'm guessing you guys are fine from here, but I'm gonna go ahead and walk through this one all the way through. All right, so what I always said was you factor the first two terms separately from how you factor the second two terms. So those first two terms I'm gonna factor a k out, and I have a k plus 4 in my parentheses. For the second two terms, I'm gonna factor a positive 4 out, and I have a k plus 4 left over. This worked out exactly the way I wanted it to. That's a k plus 4. This is a k plus 4. And so in my final step, I factor out that k plus 4, and what goes into my parentheses is what's left over, this k and this plus 4. So k plus 4. All right, and so that's factored. That's done. Now, as it turns out, since this and this are identical, we actually rarely write the answer like this. We write it a little bit differently. What we write is k plus 4 quantity squared. So that's how that really should be written, k plus 4 quantity squared. Now, again, I know that a lot of you were able to look at this thing and say, oh, that's going to be k plus 4 times k plus 4. That's fine. But when these things get a little bit hairy is when the number in front of here is something other than a 1. All right? So we're going to look at that in just a second. Right now, I want you guys to try problem number 22 on your own. So pause the video, do problem number 22, and we'll come back together in just a second. Okay, so I'm just going to run through it very briefly. Your A was 1, your C was 24, so 1 times 24 is 24. We factor this thing out. 1 times 24, 2 times 12, 3 times 8, or 4 times 6. We needed two numbers that would add together to give us a positive 10. That was positive 4 and positive 6. So we rewrote this expression. The p squared is right here. The 10p is 4p plus 6p, and then that 24 stayed the same. Then factoring by grouping, and we get this, our final answer, p plus 4 times p plus 6. All right? All right, so if you got that, you're set. What I want to do now is jump forward to problem number 25, because problem number 25 is a little bit different, and I think that you'll be surprised at how differently it works out. So pause the video for just a moment and let's regroup at 25. Okay, problem number 25 is different because now there's a number in front of our quadratic term. It's not just 1. But with this method, and the reason I like this method, is nothing changes. We're going to do everything exactly the same. So that first step is to multiply A times C. So for us, this is going to be 3 times 10. Which is 30. All right, so now take a moment and factor that 30. All right, so once you get this factored, 1 times 30, 2 times 15, 3 times 10, 5 times 6, we are looking for two numbers that will add together to give me positive 11. Well, hopefully you have already seen that our two numbers are going to be positive 5 and positive 6. right? They multiply to give me 30, and they add to give me 11. So now we go to that next step, which is to rewrite this expression and change the 11n into a 5n plus 6n. So let's do that piece. Okay? So I've got 3n squared plus 5n plus 6n plus 10. Now at this point, we're right back to where we should hopefully be comfortable by now, and that is factoring by grouping. Right? So let's go through and factor this thing by grouping. I'm going to take an n out of the first piece. Out of the second part, I'm going to take a 2. And now I'm ready to write my final answer. All right. And there we go. So what's nice about this method is that oftentimes students really struggle anytime this leading coefficient here, this, what we think of as being our A, if it's something other than a 1. This gets a lot more complicated, but if we use this method, start off with this AC method, rewrite our expression, and then factor by grouping, we don't have to remember what the lie method is, we don't have to remember any kind of tricks, we just factor it normally, and we're able to get our answer. So it's a very good method. I really recommend you try it. Go ahead and do problem number 26 now, so you can practice it with a problem like this, and then check your answer. At this point, you should be able to go on to problem number, 32? You can finish through problem number 32, and remember, what's step 1? What's step 1? GCF. Always remember to look for a GCF first, because if there is a GCF in it and you don't catch it, it makes your answer a lot more complicated. All right, good luck. See you tomorrow. 2, I think, right? Yes.